Hello! This is lesson 10.4 about circles and the Pythagorean theorem. So we're combining a lot of skills and knowledge that we've learned, and we're putting them all together. All right, so a lot of the problems, these are not new ideas. It's just putting in context together with Pythagorean theorem, so that means right triangles with circles in some way, shape, or form. All right, so let's look at this problem. What does the direction say? All right, so we're looking for the area of the shaded region. And you know, one of my first questions is, what do you see? What do you see? What do you notice? So write down everything that you know about this. See what you can figure out. Now, I will tell you, draw the picture or print out the slides, because it's really helpful about drawing things in context of the picture. When you just put the work over here with no picture, it doesn't make as much sense. And it's easier to do the work inside the diagram. All right, so what do I know? I know this is a right triangle because the hypotenuse is the diameter. There's a theorem that says that therefore that triangle that's inscribed in the semicircle is a right triangle. Therefore, C is the right angle. Okay, so the area of the shaded region, I see a circle minus a triangle. And then, so that's what I see, right? That's what I see. So I know that. And then you say, okay, what's the area formula? Well, the area formula of circle is that a triangle is half base times height. So if I can find the radius, the base and the height of the triangle, then I can do this problem. All right, so if I look at it, the base of a right triangle is one of the legs and the height's the other one. So I know, and it doesn't matter which one's which. Okay, so now I have to find the radius. Well, we had said that the diameter and the hypotenuse are the same. So if I can find this, then I can find the radius. All right, so because it's a right triangle, what theorem goes with it? That's right, Pythagorean theorem. So this is the longest side, the diameter. So when you're doing your work, I'm okay if your work is, I would prefer your work all in one line, but you have something here, you have something here, that's fine. Because as long as it's neat enough that I can read it, I can figure most things out. So this is 552 by 2. Okay, I'm going to simplify that. So this is 4 times 113. So that's 2 root 113. Okay. And that is for the diameter. So what's half of that? Well, half of that would be R equals 2 root 113 divided by 2. So half of it would just be the square root of 113, which is fine. Okay. So that's the radius. And now because I'm squaring it, and now we're just going to do the arithmetic. Now since I'm squaring this, the square root and the square undo each other. Okay, and then we're going to take this. Half of 16 is 8 times 14. I have 100, oops, sorry, forgot my pi, 112. Parentheses, centimeters squared. Okay. So lots of great work here, lots of skills. All right, find the area of the shaded region. Okay, so what do we see? Well, I see sector, which is, right, a part of area of a circle. So now we have to say, okay, if this is a sector, oops, what's the formula? And hopefully we've memorized it. So that's a sector. So area formula of a sector is A over 360 times pi r squared. Okay, so A, so it's that's that angle, the arc. So that is the same as this. So central angle or the intercepted arc, they're equal. And then the next question is the radius. Well, the radius, is the radius 24? No, that's a chord. That's not a radius. This is the radius. How do I find that? And that's a radius. Huh. Okay, what else do I see? Well, I see that I have a triangle. I see that. Okay. And I know that base is 24. I also know that angle is 120. Well, what can I do? Now, I know we're talking about right triangles, so can I make a right triangle? So I'm going to draw a triangle here. I mean, an altitude, because I know these are equal. And that's going to cut that base at 24 in half. I also know if I cut this in half, this is going to be 12. This half of 120 is 60. I'm sorry, that looks terrible. Okay, so that's 60 inside. That means that's 30 there. I'm going to draw it a little bigger here. So that's 30, 60, and this is going to be 12. Okay. All right. Special right triangle 30, 60, 90. So this is going to be our long leg, and I want the hypotenuse here, right, which is the same as the radius. So how do I get from the long leg to the short leg? Okay. We divide by root 3. Yes, you have to memorize this. So when you do the special right triangles and we really apply them, it's just one part of a many-stepped problem. So if you take a really long time just on finding this part, it's going to take you a long time to find the final answer. All right, so that's the short leg, 4 root 3. How do we get from the short leg to the hypotenuse? We double it. So we just double the number on the outside, which is 8 root 3. So that's going to be my radius. Just making space. Okay. So 8 root 3. So this is going to be 1/3, simplifying. Remember, we're going to square. So this is 8 times 8 is 64. Root 3 times root 3 is 3. Now I do know, just to simplify quickly, this and this will undo each other. So it's going to be 64 pi centimeters squared. This is why I also don't divide by 1/3 in my calculator, because what will happen, it'll give you 0.333, and it'll give you a decimal. It doesn't always give you the right number because of just the way that calculators do. So it may give you like 63.99999 pi because you rounded 1/3 to 0.33333. It's one of the reasons we do not do that. And we hope that it's just going to simplify out at some point. All right, next problem. All right, find the area of the shaded region. What is that called? Okay, you have to know these terms. What is that called? Not a sector. That's what we had last time. This is called a segment of a circle. The segment of a circle is a sector minus the triangle. So then you write the formula. So the area of the sector is this minus the triangle. All right. So let's look. Well, I know that the angle here is 90, so my A is 90. Okay, what else do I see? What else do I know? I know that this, okay, is a right triangle. This is the hypotenuse. And this is a radius, and that's a radius. Okay, so that tells me they're equal. So therefore, it is a 45-45 triangle. So remember that the radius is also the base and the height of the triangle. All right. So because it's a 45, 45, 90, I can find the radius using this hypotenuse 10. So how do we get from the hypotenuse to a leg of this special right triangle? Correct, dividing by root 2. Okay, so r equals 5 root 2, so does the base and the height of the triangles. Okay, so coming over here, it's pi 5 root 2 squared times half root 2 also squared. So this is going to simplify to 1/4. So 1/4. Okay. 5 times 5 is 25. Root 2 times root 2 is 2, and pi. Okay. So I know that 2 goes into 4 2 times, so this is going to be 25 pi over 2. Now, this is the same as that, so that turned out to be half times 25 times 2. Right? 5 times 5 is 25. Root 2 times root 2 is 2. Those undo each other. Centimeters squared. Cool. All right, next problem. Find the area of the shaded region. Lots of shaded regions. Ooh, this one's a pretty purpley color, maybe? All right, so what do I see? Okay, well, I know I have a triangle, but that's kind of a funky shape, right? Well, so I have a triangle somewhere, so I'm going to highlight that just to focus on that. Okay, I can see. So I have a triangle, and what they're taking out, this white part looks like a sector, right? A pizza slice. So if I can find the whole area of the triangle, area of the triangle, minus the area of the sector, that's going to get my answer. All right, so area of a triangle, half base times height. Area of a sector, angle over 360 times pi r squared. All right, well, I know this 30, so I know their special triangles 30, 60, 90. So is this a 30, 60, 90? Well, let's see. AB looks like the tangent. Okay, this is the radius. And radius to tangent is perpendicular, so that is 90. So that's going to be 60. All right, so that's a long leg. This is a short leg, and that's the hypotenuse. Okay, so I need to find the short leg, which is the radius. Okay, so from the long leg to short leg, we're going to take 15 and divide it by root 3. Have to rationalize the denominator. So I'm going to have 15 root 3 over 3. 5 root 3. Okay. So that is the short leg, but it's also the radius. Do I need the hypotenuse? I don't think so. The base is here, and the height is here. Again, in a right triangle, the legs are the base and the height because they form the right angle. Okay, so what is the A? The A is 60, right? And the radius we saw was 5 root 3 squared. Okay. 5 times 15, 75 root 3 over 2. 6 goes into 36. Yes, it's good for you, again, to practice your fraction work. 5 times 5 is 25. Root 3 times root 3 is 3. 3 goes into 6 2 times. So I have 75 root 3 over 2 minus 25 pi over 2. My unit is inches squared. Don't forget to put the parentheses around both numbers, or you'd have to write inches squared, inches squared. All right, so that is the Pythagorean theorem, circles, and also area with those. Look at each problem, ask yourself what you know, what you're given, and how I can use that to get my answer. Okay. Thank you for watching. Have a good day. Bye.